Well, hello everyone. Welcome back to Adrian's Digital Basement 2. We're back on the Magnavox Philips 13-inch TV that I worked on recently. This is the television that had those two jacks that were added to the side that I didn't know what they were all about. So in part one, which I'll link down below if you haven't watched that yet, I investigated what those were all about. It seemed that someone had tried to drive the deflection yoke directly. So these were connected directly to the horizontal and vertical deflection yoke. Well, I restored the connections of the deflection yoke back to the way they should be, connected that up to the main board, and I have a spare main board right here that I was working with, but I connected it back to the original main board that was in this set. But when I turned this thing on, it actually just seemed like it was shorted. The power supply would just keep clicking over and over again. That's indicative of the switch mode power supply not being able to start. It turns out with this particular set, and we'll just use this extra board here as an example, the switch mode power supply generates the B plus all the time, which I think was what, like 90 volts or something like that. Even when it's just off but plugged in, it's generating the voltage. The way the set quote unquote turns on is when you push the power button, the main jungle IC that generates the horizontal deflection starts up and should start generating horizontal deflection, running that through the horizontal output transistor to the deflection yoke and to the flyback, which has been removed. Where is it? Oh, here it is. This is the one that was from this board. And once that starts generating a signal, then you get the high voltage, you get a bunch of other voltage rails that run the rest of the set and everything comes on. Well, the reason why the flyback is off this board is because I thought I might have to swap this flyback onto the board that's in the TV, even though the boards are substantially different, but I thought maybe it was a close enough match that it would work. Turns out I didn't actually need this because what I figured out is that if I fed, I think 30 volts into the B plus and I was using my bench power supply, well, the short would reappear. And it had nothing to do with the flyback. I could remove the flyback and the short would still be there. So all that's really left on the B plus rail that could cause the short was the horizontal output transistor. Well, I took the transistor off of this board, put it onto this board, and while that did clear the short, so the power supply can start up now and generate the B plus, the horizontal output transistor that's on this set becomes very hot. So that makes me feel the drive signal that goes to horizontal output transistor, which is connected to this heatsink, it's gone on this board, but on the one that's on here, that signal that comes from the main chip is not getting to the horizontal output transistor, so it's just turning it hard on. So it's conducting, and of course that makes it get really hot, and that's probably what killed the original one that was in this TV, is that failure probably happened, destroyed the horizontal output transistor, and if I leave it running, if I say plug this into the wall, and left it to conduct the way it's doing, like when I first turned this on, it would destroy this one as well. And since I don't have any other spares except for that one, I don't want to do that. So what I want to do in this video is we'll get this TV back apart, get the board out, get into the service position so I can probe the underside. And I want to take a look at that drive signature that's coming from the main chip. We need to make sure it's there because when I push the power button, it needs to start generating that 15.6 kilohertz to boot up the TV essentially. I'm using a 100X probe, so this is a 100X probe. Makes it a little bit safer to probe around the voltages that you have inside of this thing, because of course, even with a 10X probe, that just divides the voltage by 10. So say it's 90 volts, well, that means 9 volts is going into the oscilloscope, but of course with 100X, it divides it by 100, so 90 volts is divided by 100, so it ends up being less than a volt going into here. You lose the accuracy at the low end, but it's much safer if you're probing high voltage stuff like a CRT. So let me just spend a moment to get set up so we can continue our testing. Right, so this is the service mode. So all the cables are currently still connected to everything, so this set could run in this configuration. There are two ICs on this particular board, the revision of the board that is. This will be the microcontroller, and this is going to be the jungle IC. So it handles the video processing, plus all the sync generation, all the other TV related functions that used to be in more discrete circuits are now all integrated into this. There should be one more small IC, it's probably on the other side, maybe it's that package right there. I see a row of 8 pins. That'll be an I2C EEPROM or flash memory chip that will load the microcontroller's code, or it stores the settings essentially for the TV, because this board is almost certainly going to be used in other TVs, like 19-inch versions, and who knows, that chip could be used in a whole bunch of other things. So that contains the software that boots this thing up. Basically, this thing will sit there in a standby mode. So even though B plus is running, there's power to the microcontroller, you turn it on, and then that will instruct this almost certainly over an I2C bus to start initiating the boot sequence, which should tell this chip to begin generating the horizontal drive signature, which goes through some circuits to start making the waveforms needed to run the flyback, run the deflection, all that kind of stuff, plus the vertical and everything else. And a reminder of what was happening before is I would turn on the set, and while it was not conducting, the horizontal output transistor was not getting hot normally. As soon as I hit the on button, the set would look like it did nothing. It was kind of like dead. but then I could use the thermal camera and I saw that the horizontal output transistor was starting to get very hot. And that was because, like I said, it was conducting full time. One thing I'll mention is this is the horizontal output transistor that was in this set before. And I mean, this is a big spoiler, but the crazy thing about the way this failed is that at lower voltages, this was totally fine. It would look like a normal, correct horizontal output transistor. But once you gave it something like the B plus 90 volts, or even through the bench power supply 30 volts, it would look shorted. It would look totally shorted. But if you let it sit a little while, it would go back to being fine. And you could test it with the multimeter that is, and it looked like have normal diode drop and everything like that. So this seemed fine. And that's what really threw me for a loop, is every time I went to go test this, it looked okay, which is why I thought it was a flyback and whatnot. So once the 30 volts was fed into this from the bench supply, it went short, and it would stay shorted for like 5 minutes or a minute or two, and then it would go back to looking normal. So yes, anytime I tried to start the setup, give it some B plus through the switch mode power supply, which is this section of the board, it would go short, and well, there you go. So I think the first thing I want to do is I really need to see if I can read the part number off this jungle IC. I want to see if I can find a data sheet for it. That'll go a long way in telling me, for instance, like which pin is the horizontal output drive signature that goes to drive the horizontal output transistor, because I'd like to be able to probe directly on there. Maybe we have something like a broken component that's somewhere along the way that's causing that signal not to make it all the way to the horizontal output transistor. And one thing that's kind of annoying is I can read the part number on that, but this one is really hard to read. So I'm going to try to clean that off, and using the flashlight didn't really help. I'm going to grab some acetone here, and I'm going to see if I can clean off whatever coating's on there. It's like maybe some kind of conformal coating. Maybe I can get a better read on that. Okay, yeah, what's actually on there wasn't conformal coating. There's just a little bit of flux residue. Okay. There we go, no problem reading that chip. Now it's a Mitsubishi part, which is really odd because Philips Magnavox made all the chips they needed for running televisions. In fact, the other TV, the other board I was showing, that had a Philips part on it. So why are they using a Mitsubishi chipset on this TV? Yeah, you got me. But I'm gonna try to look this up and see if I can find the data sheet. Right, a little bit of searching, I have the data sheet, the NTSC TV signal processor. It's a solution for NTSC color televisions. It has I2C bus, controlled NTSC1 chip, consists of various processing blocks, power supply, video IF, sound IF, luminance, chrominance, OSD display, interface HV deflection. Here's our pinout. Looks like right there. Pin 7, horizontal output. That is the signal that needs to get its way through various components to the horizontal output transistor to drive it. And unfortunately, if that pin is stuck, when we measure that, if there's nothing coming out of that, I guess we could check, some of the other inputs that are going into this thing. Maybe there's an oscillator input or something. But if that is stuck, well, this chip is dead, and I think I'm going to condemn this TV. But I won't jump ahead. I'm just going to, go through the troubleshooting process here. I'm also noticing there's a horizontal VCO feedback, horizontal voltage controlled oscillator feedback. Could be there's something wrong with the feedback circuit that's causing this not to oscillate. We'll have to just keep reading through the data sheet because, how many pages is this? 51 pages. Hopefully it has a little bit more about how it should work. Power on, control in. That's obviously the power on input that comes from the microcontroller. When you hit the power button on the TV, that should start this chip up. Looks like there's chroma input. So this thing obviously does support YC. Obviously it's not on this set. Yeah, like external chroma input, external Y input. We also have RGB input down here on the bottom, pins 20, 30, and 28. That could be for OSD coming from the microcontroller. It could also, it could be for like SCART type input as well. We'll need to keep reading in here to see what those inputs accept or are looking for. I don't have a schematic for this TV, by the way, and I looked for it and I didn't find anything, so we're kind of operating without that. But here's a block diagram for the jungle IC. And let's scroll over to horizontal output. So there's RGB out, RGB in, that's not what we really need. There's the I2C connection. Here's the vertical section. We're not really too worried about that. Horizontal output. Here it is, down here at the bottom. H out, H phase control, that's internal control. Horizontal countdown. If we look over here, there's a VCO adjust, vertical controlled oscillator. Now this is internal to the actual set, or to the jungle IC. So this line along the bottom where these pins are, this is all inside the chip. So yeah, there's the VCO adjust. There is an input into that, pin 4. So I guess we need to look at what's on pin 4. It just shows it having a capacitor and hooked up to ground through a resistor. But maybe this allows for like external horizontal hold kind of thing. VCXO, yep, so this is just some kind of internal oscillator stuff, VCO adjust. Yeah, there's a lot of oscillations, things that are happening inside of here, because like here's another VCO adjust. This is for VIF, video IF, intermediate frequency. This is for the RF portion of the chip. This is all inside the chip again. Looks like VCO has another adjustment connector there. So the video detector, yeah, this is all like video IF, RF stuff over here for the tuner. And this is very super typical with these. So this whole section inside the chip is the tuner section. It's taking the output from the tuner and converting this into a video signal. And it actually comes out of pin 57 as a video out signal. And very common with these is that signal comes out of the chip and actually loops around. So we follow this trace down around here and it goes back into the chip as TV in or Y in, chroma in, depending on if this is in chroma luma mode or not. It would typically, depending on the programming, because it's I2C controlled, it would just be composite video input. So it's really funny, these chips typically do this. Yes, it'll decode all the RF stuff and then give you a video output, which could go to a jack, that could go to like a VCR or something. But typically, this is very common, is it just loops right back around and goes back into the chip. So if you have an external video input, which actually is this, and there's some internal switches, that's what's happening right here, but the TV input just comes right back along, it goes back into this thing, and then this goes through all the color demodulation and video processing stuff that's happening right here. Demodulators is all like for color stuff, chroma trap, delay lines, it goes into a matrix switch that lets you control brightness and contrast and stuff like that, and that makes its way through all this drive amplification, clamping and stuff, horizontal, vertical blanking, and then RGB output. That goes to the neck board itself to actually generate the video signals. So the funny thing is with these types of chips is, you have an external video input here, it supports that, and it's wired up on this set. But say you want to use the tuner as another video input, well, you can do that. You can just disconnect this connection. It goes from the output of the tuner section and feed another video input into here. And when you go to the menu and you switch between tuner and external input, it actually switch inside the chip here, and you have two video inputs. Now, to get this thing to work in YC mode is not likely to be easy, not without changing the programming on the microcontroller, because that stuff is all controlled, the state of these switches and everything, by the I2C bus. Now, what's funny is on some of these chips, I don't think this one is, the video input goes in, composite video comes in, and out comes YC, or like Luma Chroma, S-video style signal, comes out, loops back around going into the set, and theoretically you could feed YC directly into it, like a Commodore 64 or something, by just breaking that connection. But it doesn't look like that's actually happening inside this set. This seems to go directly from the color decoding right into the matrix switch and into the rest of the chip. So anyways, I've gotten way off topic here. What we need to figure out is what's happening with this whole oscillator stuff, like this voltage control oscillator for the horizontal and vertical. There are some signals down here. It says FBP INV out and FBP in. I wonder if this is some kind of horizontal feedback circuit that maybe goes to the flyback or whatnot. Don't know if it's 100% used or what it's used for. We'll have to look at what those pins do, 6 and 12, but it's definitely related to the whole horizontal section. If we just keep looking through this document, like what we're seeing here is the table for the I2C bytes that you can write to do everything. So you can like switch to the YC input. There's probably an RGB input thing on here. Looks like it has FM radio support. There's other stuff in here. All the various controls for like cut and drive signals for the RGB output is all done inside of here. It's all pretty typical stuff. Yeah, this is all the I2C stuff that you can adjust. The service menu on this TV may or may not allow you to adjust these things, but it's certainly stuff that this chip actually supports. Like, yeah, this is all like RGB brightness control, analog, OSD. So you can actually switch the OSD on-screen displays between analog and digital. If it happens to be an analog signal, that means we could just feed an analog RGB signal directly into the OSD inputs. I have no idea how this is configured though. We have to just probe those signals going into this chip, if this TV ever works, that is. And if it is analog, which means the voltages are from 0 to 0.7 volts, then we could just do that. Otherwise, the problem is the firmware for the set that's on the microcontroller sets this stuff all up. So we can't just override these values, not without reverse engineering the whole firmware and changing that stuff. I'm just taking notes on a few of the pins. So horizontal output is 7, horizontal VCC, 8 volts, looks like. That's worth checking. Say there's no voltage there, then that means that maybe the whole section of the circuit's not running properly. Here's this feedback stuff. Pin 12 is FBP INV out, whatever that is. Pin 6, FBP in. And the last pin we're caring about is the voltage controlled oscillator horizontal, pin 4. I'm going to put a star next to the things that seem important and are worth checking. So VCC 8 volts definitely, horizontal output definitely, and this FBP in signal. And I guess we can take a look at this voltage control oscillator input as well, but that's only if we don't see a signal. I mean, honestly, if we're seeing an output signal here, I wonder what the input signal should look like, this pin 6. I don't know, not quite sure yet, but at least that gives us some info. All right, let's keep going down here to see if we can figure out what's what. This has to do with the chroma. This is like the video detection stuff. None of it is particularly relevant to us. This is actually like kind of telling you how to set up your I2C stuff. So like when you're programming this chip, this is how you do it all. Okay, here, all right, here's a section here. All right, measure the output frequency at pin 7 when no signal is input. It says here that if you set the free running oscillator mode to on, this is an I2C thing, then we should start seeing an output from that pin. Now, of course, this TV is going to be configured in that mode because it needs to show something on screen when you turn it on. So we don't need to worry about that being set to off. That means essentially if the signal is not having a good sync signal that it can't log onto, the TV is still going to run. It's going to generate a horizontal output signal. And then once you input a valid video signal, it'll lock onto that. But with this free running set to on, which I'm sure that it is, it should just generate that signal all the time. So does this tell us what it looks like? I mean, I don't know. We know what we need to look for. We need to look for 15.6 kilohertz or thereabout. And here's talking about vertical stuff, so we don't need to worry about that because that's not our problem. So this is what's inside the chip when it comes to the voltage control feedback. Like these are the parts that we can't control or whatnot. And see there's pin 4 comes in and has that stuff hooked up and, you know, whatever signals happen, I guess. All right, here's this FBP in signal, pin 6, DC voltage. FBP low is 2 volts and on is 1 volt. Well, I guess that's kind of what you're expecting on the input to this. Again, not 100% sure like where this is actually coming from because it doesn't really explain that in here. I don't even know what FBP stands for. Horizontal output is 0 to 5 volts, so okay, we know what to look for there when we check that signal. Going back to here, it just says 3 volts. Well, remember it's hooked up to ground through a cap, at least on the sample circuit, so who knows? That's all there really is for us to worry about. So unless there's a better explanation of like what these things do, let's keep scrolling down here. Oh, that's it. So there's no real explanation of like what those signals are. Like what's FBP? Let's search for that. Maybe I missed it. FBP in? FBP VL? I mean, what? Pin 6 FBP slice level switch. VTH equals 2 volts narrow or 1 volt wide. Huh? Well, that really, that tells me nothing. And keep on searching, and there's pretty much nothing. Well, the only reason why I think this is kind of related is because FBP input here on the block diagram does go into this H coincidence, I think, detector or something like that. It also makes its way up. Let's see where that goes. Over here, oh, horizontal blanking. So there's some feedback circuit to blank the cathode drive while the horizontal blanking is happening, but also the vertical countdown is happening, so it also blanks for the vertical. But it does seem to be connected internally to this invert or INV thing, which does make its way out. There's a FBP INV out, and I don't know. We'll need to look at how this is actually connected on the board to kind of see what's going on. Okay, so good thing is we have an idea of like what pins on the main chip we need to look at when we power this thing on and try to turn it on. But one thing we need to do first, before I even try to power this on again, is I need to remove horizontal output transistor. I don't want to risk damaging that horizontal output transistor since it's the only one. Now, the thing is, the signal that comes from the main chip, which on this board is that large IC, that signal doesn't just go, horizontal output does not go directly to the horizontal output transistor. That's because if something goes wrong with the horizontal output transistor, like it shorts, like it did in this set, what would happen is that 90 volts would just go back to the chip and absolutely destroy it. So typically what happens is the output of this goes into a little transistor, a small drive transistor, and then there's a little transformer, and that galvanically isolates the high voltage side, the B+ side, from the chip here. So if the horizontal output shorts like it did on the other set, well, that transformer protects it from getting back to the chip. Well, I don't see a transformer on this board. I mean, there's a little transistor here, which could easily be the drive transistor for horizontal, but where is that little transformer? I don't see it on here, but I can tell you that I've removed a whole bunch of components from this board already. So it's possible that I just took it off already and that's why it's not on here. I can tell there's like multiple caps that have been removed. There's also a bunch of corrosion on the board right here and a broken jumper link, so I don't know what's up with that. But, oh, you know what, actually? I bet you this component right here, this little black component, that's probably the transformer. If we look on the back, yeah, it's got 4 pins on it. I thought it could be a coil. Sometimes those can be just coils, but the fact that it has 4 pins, that's probably the transformer right there that drives the horizontal output. So on this board, it's going to be very similar. That is probably the transformer right there, because the horizontal output transistor is on this heatsink. That probably is going to be driving that. Now, it's possible that component's bad. Maybe when it shorted, it took it out, and that could be why we're not getting a signal. And I wouldn't be surprised if, like, this little transistor right here that I have the pointer on, maybe that's the actual drive transistor for this transformer, and then it goes to the actual big horizontal output transistor. Best thing we can do, though, is I need to take this horizontal output transistor out so it doesn't damage it, and then we just need to turn the set on and measure the output from that surface mount IC on the bottom. Now we know the pin number, and we need to look to see if there's actually a correct horizontal output drive signature coming out of it on the oscilloscope, because if there is, that's great. That means we have a component that's failed on the board somewhere else. Unfortunately, if we don't have a drive signature, that's why I'm talking about maybe condemning this set. You know, I'm not gonna try to take that surface mount chip off the bottom. No, that's not happening. Not for a boring television like this. I'm gonna turn on the desoldering iron, and I need to get the horizontal output transistor out. It's that component right there. And once it's out, I'm probably going to spend a moment just with the camera off, and I'm just going to trace the horizontal output signal, whatever pin that was, 7, I think it was. Yes, pin 7. I'm going to try to trace that all the way through to the base on the horizontal output transistor that I've removed, so we can see exactly what components are in between. There's the horizontal output transistor. Safe out of the board. All right, I'm just gonna spend a moment with the camera off to trace it out. I'll draw on the board with a marker so we can kind of see the flow from the main chip all the way to the horizontal output transistor, the base of the horizontal output transistor. Right, traced it out for the most part, good enough for troubleshooting, and I've drawn it out on this piece of paper. Hopefully I get the camera to focus. So that's the jungle IC, pin 7, that's the horizontal output. It goes into a 10K resistor, labeled 3243 on the board. That is good. I mean, there's continuity, well, 10K through it. It goes through a jumper link 3709. That goes into the base of the small switching transistor that's driving the transformer. I don't know what the emitter goes to. I can't quite tell. But the collector is going to one of the pins on the transformer. The other pin goes off to something. I'm not sure what. And on the other side, one pin goes to ground, and the other pin is going to the base of the horizontal output transistor. One side of that is connected to ground, and the other side probably goes up and, you know, is hooked up to the coils and the flyback and stuff like that. So what's happening is the B plus is going into the, say, the flyback, which is a transformer, into the deflection coil, things like that. So that 90 volts is just sitting there. But when the horizontal output transistor gives a pulse, what that does is it grounds the B plus that's going through or into the flyback, into the deflection yoke, and that causes that to collapse. And that's, of course, starting to generate that high voltage. This pulse is at that correct speed, 15.6 kilohertz. So really what we should be able to do is with the oscilloscope, we should be able to see the drive signature coming out of this chip. We should be able to trace it all the way into the base. We should be able to trace it going into this transformer, and we should be able to see it coming out of the transformer going to the base of horizontal output. We'll start over here. If we don't see a drive signature, uh-oh. But if we see the drive signature there, then maybe, you know, maybe there's a fault. Maybe the transformer's bad. You know, who knows? This is what we have to start. We have to start poking around, see what we see. We need to find that drive signature all the way through this entire path, all the way to the base of the horizontal output transistor. Now remember, I removed the horizontal output transistor, so trying to turn this set on with that removed means that it will never conduct. So the B plus will just stay sitting there on the flyback, and there will be no overheating of that particular component. I've asked a few friends who are CRT folks, and they said that doing that should be fine. Some older sets, you probably need to have a diode in there to kind of simulate the transistor, but in this particular set, I don't think it matters. Right, so we're set up at 2 volts per division, and I think we're ready for testing here. So just to remind everyone, I have the ground lead connected to the ground on the set. So just to remind everyone, it's this resistor right here, that's the 10K that comes from the horizontal output. So I'm going to put the probe on the side that faces the jungle IC. I'm going to turn on the set. Okay, set is live. It is live right now. So I'm going to try to turn it on now by pushing the power button on the front. Oh yeah, we have a drive signature. I'm going to turn off the set, see if it turns off. Oh, it does, it stops. Okay, so that means the microcontroller, oh, sorry, you couldn't see what I was doing, but the microcontroller is responding. Uh-oh. Okay, now the set's not turning back on. I'm going to recycle the power. Maybe that's like that feedback circuit, or it knows it wasn't running. So we'll turn the power off, power back on. Here we go. Okay, there's our drive signature. I need to get the trigger set up though. There we go, 15.6 kilohertz. Right. This is good news, everyone. This is a good news. This is telling us that that chip is generating the correct signal. It doesn't seem to be getting to the base on the horizontal output transistor. So what I'm going to do is I'm going to try this again. I have the set off. I'm going to turn it back on from the power switch, that is. And I'm going to measure the other side of that 10K resistor. Ah, look how low that is. So I'm wondering if this little transistor, which I have the probe on now, is somehow shorted. So let's turn this on, turn the set on. There's that weak signal. Let's check the collector side. Oh no, it's nice and strong now. Let's change the volts per division on here. I don't know what it's actually running at. I don't know, I have it at 20. So now I'm on the pin that goes to the transformer. Okay, let's turn this on. All right, there's a drive signature there. Okay, it is responding when I turn off and on there. It's actually coming and going. Let's try 10 volts per division. I don't really know what voltage this should be. 10 volts per division, there it is. 15.7 kilohertz, good enough. Right, so what this is telling us, the drive signature makes its way from the main chip through the resistor, the dropper resistor, through a jumper link, goes to the transistor, that little small drive transistor, and it's going to the little transformer. It's going to one of the two pins on the transformer. I don't know what's on the other pin. It looks like maybe, well, 9 volts according to this. The set is currently on. I mean, there's power to it. It's not running. I have the power switch, you know, well, the soft power switch off, so there's no drive signature. So we're just seeing 9 volts. I'm not sure if this is like a one-to-one transformer, like the primary and secondary side, or what. Check the output here. This would be going to the base, to the horizontal output transistor. Currently, there's nothing. I'm going to turn the whole power of the set off, back on, press the button. Oh, that doesn't look good, does it? So on one side, we have the drive signature, but on the other side, we have what looked like nothing. I mean, it was just barely there. Is that normal? Let's change it to 4 volts per division, and let's do it again. Turn it on. I mean, 2.2 volts peak to peak. It's hardly anything. And then the set shut down. All right, I killed the power to the whole board. This is where I don't know the way this should work. Is 2.2 volts peak to peak normal, or is there something wrong with that transformer? The other side of the secondary winding is connected to ground. That's this side right here. So that means when it's in an idle state, there isn't really any voltage being generated. But then it should couple, because it's a transformer, right? So when you have something on the primary side, you should start getting something on the secondary sides. But that base drive looks weak, but maybe that's all you really need for the base drive when you have a horizontal output transistor on there. Now this is the base drive, so that's the base right there with the circle around it. It looks like there's maybe a resistor right there. Let's measure what that actually is. And remember, the power's off to the whole board. Okay, hold on a second. What is this? There's like something shorting the base drive to ground. Whatever this component is, 37, looks like 67. I didn't write that down on my little diagram here. What I'm measuring is the signal that comes out, the base drive that goes to the horizontal output. There's actually some component that is connected here between these two. I thought it would just be some kind of resistor or something. What if that's a diode and it's shorted? That horizontal output went short. Maybe if that's a semiconductor, it took it out. So let's investigate what that part is right there. All right, no, that's just a resistor, and it doesn't look like it's blown up. And I realize now why it shows up as almost 0 ohms, because we're measuring the secondary, the windings in the transformer. The only way to properly test that resistor would be to lift one leg or remove the transformer. But it's just a normal tiny resistor, and those resistors, they're not going to go short. They'll fail open and they'll be burned, and it's not burned. So that part is fine. So again, to measure that resistor there, we'd have to just lift one leg of it or remove the transformer, and then we could measure that. Okay, so I'm stumped. There's a base drive signature going into the base of the horizontal output transistor, and yet when the set tries to run, I mean, I guess I could put the transistor back in there, we could measure the base and just see if this thing is even running. You have to be very careful measuring a horizontal output transistor while the system is running. The base is fine because that's just a little bit of voltage coming from the base drive over here through this transformer. But the collector side that's facing the coils of the flyback and the deflection yoke, that has some serious spikes on it. So I think what I need to do next is I need to ask some CRT friends what they think about the base drive voltage, what voltage should be going to the base on the horizontal output transistor, to see if what we were seeing was appropriate. You know, we had a few volts there with that drive signature. We had a drive signature there though, for sure. So, you know, we could have a problem still in that circuit. It's just weird that as soon as the set ran, we had no high voltage, we had no horizontal drive going through the flyback and whatnot, and the horizontal output transistor was getting really hot without actually generating a high voltage. I mean, I wonder if we still have a short somewhere. As a side note, I measured the inductance on the coils, both of the horizontal and vertical, totally fine. No short in this. Well, at least not at the voltages of my test meter. Flyback again, I don't know. I'm not 100% sure what's going on. It's not shorted on the B+ side, but maybe the horizontal drive side is bad. I suppose another possibility is that this horizontal output transistor I stuck in there is not compatible with this set. You know, it came from that different board. Let's pop it into my tester here. I don't know if I tried testing it. Okay, yeah, it's just an NPN transistor. That is how it should look. And it says pin 1 base, pin 2 collector, pin 3 emitter. And that absolutely is what matches here. Pin 1 was the base, collector, emitter. It's marked on here. So the pinouts for this match what's on here. I was just examining the traces on the spare board, the one I took the output transistor from, and without a doubt, this little component right there with my pinky, that is the transformer on this set that takes the horizontal drive and brings it to the horizontal output transistor. Yeah, I can see the base makes its way to a jumper link. It goes around, and it goes to that pin right there. And on this side here, there's a little tiny transistor. That's what's driving the primary on this side. So I'm a little bit confused because I really feel that that horizontal output transistor should work. And we're obviously getting our drive signatures from the main Mitsubishi chip, but why is it just causing this thing to kind of go into continuous conduction mode, which makes it get hot and overheat? What's going on here? What is going on? I just did a little search on my phone here, and this is like this repair fact, and I was talking about the horizontal drive section, and it says the schematics show the peak-to-peak voltage ranging from 5 volts to 30 volts, but much of that amplitude is due to the voltage spikes caused by the switching action. The waveform only confirms the presence of the drive to the horizontal output transistor. It cannot confirm the base current drive is adequate for normal operation. Reduced or improper drive results in transistor heating, reduced deflection width, picture foldover, or shortened horizontal output life. Well, that's not helpful because I don't have the schematics for this set, so I don't really have a way to check what that waveform should look like in the set. And my assumption is if I put back the horizontal output transistor, the drive signature from this transformer isn't adequate for this transistor. You know what? I don't know if I did this in the last video. This is the bad horizontal output transistor. I have an X on it. Maybe I need to look up the data sheet for this one versus this one, and we can kind of try to compare, you know, I don't know, whatever it wants for the base current drive, stuff like that. You know, I just had a thought. Maybe the resistor that's installed here, the one I couldn't measure because it's in circuit with the secondary, maybe the value is wrong. And maybe I need to take the resistor that's on this board and transfer it over. I can see that the resistor, instead of being near the transformer, is actually right there, next to the base. There's the resistor that's on the parts board. Looks like it's yellow, purple, black, gold, which equals 47 ohms. Okay, would you believe that the resistor that's on the set that's not working is also yellow, purple, black, gold? Same exact part. Okay, well, I don't know. Of course, one difference is the transformer is different and maybe this one's damaged. Problem is this one here has a different footprint, so I can't easily transfer the transformer over to this system here. Not to mention maybe the ratio between the primary and secondary is different because of course this is a different chip on here driving the whole horizontal versus that one. Okay, I think I need to go back to looking up the data sheets for these two horizontal output transistors to try to see if I can figure anything out for that. All right, I have the two data sheets. This is the one that died, the BUP11APX. This is the one that was failed. 1000 volts, collector emitter, 450. Looks like this thing can conduct 5 amps continuously. And if we take a look down here, base emitter saturation voltage, I think this is the relevant part we're looking at, or collector emitter saturation. Yeah, I think base emitter 1.3 volts, and that's at 2.5 and 0.33 amps for the current. And this is the part that I'm trying to use in the set here. This is a BUL 312FP high voltage. It's very similar looking. It does say horizontal deflection, the other one didn't. Voltage is 1150 and 500, so a little bit higher than this one, which was 1000 and 450. Current capacity, 5 amps, very similar. But if we look at base emitter saturation voltage down here, let's look back here. This is 2.5 and 0.33. So 2.5. So 1.1 to 1.3. So it's probably about 1.15. You know, it's kind of in the middle here. Although the base current's a little bit different because with the other one, the base current was 0.33 amps. And here, that would be at a different voltage threshold. So it's slightly different. But again, I'm not 100% sure on all this stuff because these kinds of transistors and all of this is a little bit of the analog magic I don't really fully understand. So I don't know if those are really direct fits for each other. I would imagine they are, but again, I'm not 100% sure. I know that that resistor on the side of the transformer is the same for both the spare parts board and this board that, what was it, whatever, I looked up on the phone, whatever it was the same. So I can't switch those parts out. But when we look at the scope with the transistor removed, we see a normal waveform. It seems to go down to ground and all the way up to like, I don't know, whatever it was, 2 volts or something like that, which should turn on the horizontal output transistor. It should be working. Again, I'm super confused. So I might need to send both these data sheets to my CRT friends and see what they think when they look at both, if this is a swappable part, or if maybe my problem is I'm just trying to use a horizontal output transistor that's not appropriate for this set. So I had a brief chat with my friend Sark, and he thought that this replacement horizontal output transistor should work without issue in this set. And when it comes to the voltage that's going to the base of the horizontal output transistor, well, Sark thought maybe it seemed a bit low, but Sark did indicate that it was normal for the transformer that's going from the jungle side to the horizontal output transistor is normally a step-down transformer. So higher voltage on the primary side is normal compared to the secondary side. And remember, we're seeing like 2-point-something volts on the secondary side and like 9-something volts in the waveform on the primary. And unfortunately, my camera mic died, the battery that is, so I'm recording a voiceover here, which I really hate doing because it's such a waste of effort. So what I decided to do is measure the impedance of that transformer. I thought maybe there's a possibility that the transformer that has the secondary that touches the horizontal output transistor somehow got damaged when the horizontal output transistor shorted. Because I have my second board, my spare board here, and it has a little transformer, and I think earlier I measured the resistance on both of them, and it seemed like the resistance was higher on the spare board. So the secondary resistance on the original board here is down around 0.26 ohms. Seems really, really close to a short. And measuring the same points on the spare board, you notice it's at 0.5453 ohms. So the resistance is higher. Don't know if that's a good thing or a bad thing. It's just different. Now the primary resistance on the original board, or the one I'm trying to fix, was about 4.5 ohms. And on the spare board, it's very, very similar. 4.8, 4.9 ohms. Getting a hard time getting contact there for 4.8 ohms. So while the footprint is different, the primary seems close enough and the secondary seems, I don't know, maybe a better match for the horizontal output transistor I'm using in the board I'm trying to fix. So I'm going to swap them over. Well, I'm going to swap the transformer over from the spare board onto the board I'm trying to fix, even though the footprint doesn't fit. I'll make it fit. Sorry about that. I know I ran out of audio there. My wireless mic ran out of battery. I really need to get new ones. The batteries are completely worn out on those. So I switched to a different set while the other ones are charging. So I did is I took the little transformer for the horizontal drive and I added a couple extra little offcuts so that I could use this one from the spare board on here. Maybe this one works better with this horizontal output transistor, the one that's from the other board. So pulling that off, I had to extend the legs just because, well, it just wasn't going to work. These two I could just bend a little bit to make it work, but I had to add these little offcuts and I bent them up to shape. So hopefully that should work in here. Let me get this soldered in. It's in the board. Let's just double check that I have this around the right way. 5 ohms on the primary side, which is correct. That's what we expect. And this is where we were seeing like 0.3, 0.2, and now we're at 0.5. And I don't know if that's good or bad, but my assumption is maybe that will result in a different drive signature to the horizontal output transistor than we got with this little original one that was on there. All right, so the scope is ready. Remember, I have the actual horizontal output transistor installed in the board. So if this thing decides to work, the TV's actually gonna run. I'm just gonna make sure everything looks safe and okay to run. The ground, yes, the ground connection is connected. High voltage anode is connected. Everything Everything looks like it's connected. So this thing is ready just in case it works somehow. I don't really believe it's going to work, but I guess anything is possible. So I think what I'm going to do is I'm going to clip right onto the base on the horizontal output transistor. Now that the pin is there, I can actually hook onto it. Let's increase this to 4 volts per division, just in case something weird happens. Let me turn on the TV. Okay, B plus is there, I hear it. I'm going to try to turn it on. Let's watch the waveform. Huh. So let's go back to 2 volts. I'm going to reset the set. It seemed like maybe it started there. I don't know. Maybe not. That waveform sure looks different, doesn't it? You see that waveform that it was doing? That looked different than it did before. So I'm clipped onto the collector on the horizontal output transistor. This is where there is a ton of voltage if the set is running. If the set's not running, we should just see like 90 or so volts on here. And I'm not going to turn the set on. I'm not going to try to turn it on. Meaning I'm not going to hit the on button. I'm just going to look at what the voltage is when I turn on the power. Okay, so that goes way up there. And it says 102 volts, which is fine because B plus should be around 90 volts. So that means the power supply is running. We don't have a short. I have it set for 200 volts per division. I'm just going to try turning this on. If it damages the scope or whatever, oh well. That's why I have this cheap scope. Here we go. Okay. There's a waveform there. Uh-oh. Okay. So the set shut off and it sounded like maybe something shorted. That's not good. I hope the horizontal output transistor didn't blow up. Did I just kill it? The power is currently off to the set. I have the plug undone. So when the waveform that you saw there disappeared, that wasn't me turning it off, and the power supply or something started making the shorted sound on here. And yep, that's it. The horizontal output transistor has shorted again. You gotta be freaking kidding me. Yep, it's a total short, always. Base to collector, yeah, it's totally dead. That's it. That's all she wrote. It is dead every which way. That horizontal output transistor, that's shorted. Damn, it didn't even run that long for it to get shorted like that. And we saw that it was like trying to run, but I guess it was trying to pump a bunch of current into, let me see if the heatsink's even warm. Oh yeah, the heatsink is warm. It's certainly not burning hot though. How about the transistor itself? Not even that hot, but the heatsink's warm. So it was dissipating some current. So the transistor was dumping that B plus into something. I think the flyback is bad or the deflection yoke is bad. I don't really see what else would have just killed that horizontal output transistor. And it wasn't even running that long. You know, geez. What a freaking annoyance that this popped, because I can't really do much more at this point. I don't think I have a spare. I should look through my scrap boards from like VGA monitors and stuff that I have scrapped. It's possible one of those has one that I could somehow get to work in here, but it just has to fit in the footprint, and it may not, and that's the biggest issue. One dead horizontal output transistor doesn't look like it's bad, but obviously if we put this into here, it's just gonna show up as probably a resistor or a couple resistors. Self-test mode, yeah, that's what it does when you put a resistor, a bunch of shorts in there. Right, so another dead part. How freaking frustrating is that? And I'm just looking over here on this board. You know, there's some diodes and stuff around here, but I didn't check for those to be shorted because I just figured if those were shorted, the power supply would be shorted when you powered it up, even before you tried to turn on the set. You know, it wouldn't try to run like it did and then stop. Let's see some of these diodes here. That one's fine. There's another one, 0.6, completely fine. How about this one? No problems. There's a bunch more on the board here, so I'm just gonna quickly test these. So far, everything's good. 0.6 on that one. So everything in this section over here seems completely fine. All right, with that, 2 dead horizontal output transistors, I think I'm gonna probably end this video here. I'm probably gonna try to scrounge around to find more of these horizontal output transistors that are in the right footprint. Beware, by the way, if you try to buy some of those off eBay or AliExpress, they're all going to be fakes at this point. You pretty much have to take them off old junk TVs, which is what I'm going to try to do. And if I do find one, maybe I can give this another try. Although at this point, I'm kind of feeling like the problems with this set are beyond what I can fix. I don't see any issues in the electronics on here. I really feel like the issue's got to be the flyback. Maybe got damaged from, or maybe it's always been damaged, and maybe that's why someone gave up on this, or the deflection yoke. But the deflection yoke really looks like it's in perfect shape. There's no corrosion in this set. It would be weird if this were the problem, especially because I used my LCR meter to measure it, and I did that off camera in the first part. It looked completely fine. Let me just check the resistance on it, because someone watching this may know what good or bad resistance should look like on one of these. Okay, so first we're going to look at the resistance. It is unplugged from the board. This is the horizontal deflection, so 2.6 ohms. And then if we look at the vertical, which I don't think there's a problem here anyway, it should be higher. Yeah, 16.5. I feel like that's a completely appropriate value for horizontal and vertical deflection on here. And like I said, LCR meter, I looked at the inductance and that seemed completely normal. I didn't write it down, but I've looked at plenty of these and I just remember it was completely fine. So for me, that kind of just leaves the flyback as the only fault. That could be sucking all that current down so badly that it absolutely just kills these horizontal output transistors. Now, one particular possibility is I had this connected when the thing failed, when that thing went short. So I'm hoping there's someone watching who can recognize the waveform that they saw in here and maybe go, oh yeah, that looks like it's, you know, such and such that caused that particular waveform, like something was loading it down that shouldn't be, like say shorted turns inside the flyback, something like that. It's just so funny because you look at these sets and you'd think, oh, everything is like so simple here. There's like nothing really to go wrong, or when things go wrong, it's really easy to fix. Clearly not. I'm unable to fix this set. 2 videos and I'm still stuck and I have bad parts. So there we go. That's going to be it for this video. If you thought it was interesting in any way, shape, or form, a thumbs up would be appreciated. Huge thanks to my supporters. Huge thanks to my subscribers. Hit that subscribe if you haven't done it already. It's already free to do that, but there's links down below to go to become a patron if you want to do that, or YouTube member is also an option. You get early access to videos and stuff like that. I'd love to hear people's comments and thoughts on what might be wrong with this thing and why I just killed another horizontal output transistor. Comment down below. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.